right, today, people, we will first start off with a little review of solving linear inequalities. And then we will go, well, none of this should be new because y'all see this in eighth grade, sixth grade, seventh grade, starting in sixth grade. All right, so there will be questions that need to be asked at the end. All that good stuff will happen later for us. So let's review inequalities. Okay, make sure you're paying attention. There will be a test at the end. So this symbol right here, if we're reading from left to right, which when we don't have numbers or anything, we actually read from left to right. So this will be less than, right? That's less than. This symbol right here will be greater than if I'm reading from left to right. This symbol right here will be less than or equal to. And this symbol will be greater than or equal to. Now you might have learned this like wherever the mouth is open, that's how you know if it's greater than or whatever like that from reading from left to right. So that's what we're looking at right now, reading from left to right. Less than, greater than, less than or equal to, or greater than or equal to. All right, so whether we know it or not, we see inequalities in everyday life. Define the variable and write an inequality that fits the situation. So inequality is saying two things are not equal, right? Not necessarily equal. Okay, that's why we have less than or equal to, greater than or equal to. So that's what we get inequalities. And we see inequalities in life. You know, this whole social justice movement is all about inequalities. People are not treated the same way. So when we look at the speed limit, um, here we have the speed limit. So it says define the variable and then write an inequality for this that fits the situation. Make sure you're paying attention to this. You have the ability to rewind the video if you don't understand something, because this down here will be all you coming up. All right, so the actual subject is speed, right? So I'm going to say S equals speed because that's the subject. Now, what's the inequality? The speed limit has to be, you can go 55. Now, if you're obeying the law, supposedly, you can go 55 or below. So that means that S has to be less than or equal to 55 because that's the speed. All right. And the next one, we usually see this 20 items or less. Usually you see this in Walmart or Harris Teeter, any grocery store, where you have the express lane or express aisle, 20 items or less. So our subject would be items here, right? Subject would be items. I meant to put the I is equal to items. I'll write that over. I is equal to items. And then we're saying 20 items or less. So the items can be 20 or less than 20. So it's going to be less than or equal to 20. Less than 20, because you're not supposed to necessarily get in, those petty people. I was about to say another name, but those people that get in the aisle, you got 50 items, and good and well you're not supposed to be in this aisle. You know good and well. Hopefully that's not y'all when y'all grow up. Get out the aisle. Get out the aisle. So pay starting at $7.25. So my subject here will be the pay, right? P is equal to pay. And the pay will be starting at $7.25. So can I have lower than that? No. Can I have $7.25? Yes. Since I can have $7.25, the pay will be greater than or equal to $7.25. All right. It's going to start at $7.25. So it has to be greater than or equal to. Okay, so these scenarios will be yours down at the bottom. The first scenario says persons under 17 are not admitted. So you're writing the scenario that talks about who can't get, what type of people can't get in. All right, so if we define the variable, P is for persons, and then are not admitted. So the people that are under less than 17 cannot get in. All right, people that cannot get in. So the people that are 17 and above, greater than or equal to, can get it. So people under 17 are not allowed in. The next one. All right, hopefully you got that right. C for capacity. So the capacity is C. And then capacity for this room is 300. So you can have 300 people, but that's the limit. So it has to be, C is going to be less than or equal to 300. Now the next one, you must be more than 36 inches tall to ride. So you're thinking about you, the person, you must be more than 36 inches tall to ride. So who can ride? All right, so if I define a variable, I'm talking about you, right? Y is for you. So you must be more than 36. So you can't be 36 and ride because it clearly says you have to be more than 36. So if you're 36 inches, yeah, I won't be able to get on. All right? So that's pretty much 3 feet. You got to be over 3 feet tall. Okay, hopefully that makes sense. Let's take another trip down memory lane. Now, whether this was shown to you or not, it is very important for you to know where this comes from. I'm moving my body over here. So it says, what happens when you multiply by the same number? So I'm going to change my color. You know my favorite thing to go to is the galaxy. Y'all see the galaxy? Watch this. This is the galaxy. I miss making videos. I kind of don't because they take up too much time. I'd rather teach in person. The galaxy. We're going to the galaxy, everybody. It says, what happens when you multiply by the same number? Consider 4 is greater than 1. Now, interactively, you would move this over. So we're saying, excuse me, this dog keeps walking around. All right, so 4 is greater than 1. We know that. So when I do 4 times 3, 4 times 3 is 12, duh. And 1 times 3 is 3. So what's the inequality symbol that should go in? It's greater than. Okay, 4 times 2 is 8. 1 times 2 is 2. Okay, so what's the symbol? Greater than. 8 is greater than 2. 4 times 1 is 4. 1 times 1 is 1, so it's greater than. 4 times 0 is 0. 1 times 0 is 0, so it's equal to. Now, this is what we're doing. We're saying what happens when we multiply by the same number. So here we did 3's over here, 2's over here. We did 1's over here, 0's over here. Now we're going to do negatives. Okay, so 4 times negative 1 is negative 4. And 1 times negative 1 is negative 1. So negative 4 is actually less than negative 1. 4 times negative 2 is negative 8. 1 times negative 2 is negative 2. That's actually less than. 4 times negative 3 is negative 12. 1 times negative 3 is negative 3. Negative 12 is less than negative 3. So it says, what conclusions can be made about what happens to the inequality when multiplying by the same number? So notice that when I multiply by a negative, what happened to the inequality symbol? Okay, so it flipped. But why is it flipping? Why is the inequality symbol flipping? I wish in Nearpod I could do open-ended, but I necessarily can't. So yeah, why is it flipping? Pause the video. I should say. All right, it is flipping. This is the reason why it's flipping. The larger the negative, the smaller the number. So what used to be a large, change the color. What used to be a large positive, right? I thought I changed the color, y'all. Right here, what used to be a large positive is now a large negative. So the larger the negative, the further it is away from 0. So negative 12 is there, but now negative 3 is right here. So the reason why the inequality symbol flips when we multiply by a negative, because what used to be a very large positive is now a very large negative, which means it's a smaller number because it's further from 0. That's something that you need to write down somewhere. So the reason why we flip the inequality symbols, because when you multiply by a negative, the positive number becomes very large negative. Becomes a very large negative. Or the negative number now becomes a positive number. So you're basically changing the order of where the number appears on the number line. So I've never said that before. That's Mr. O'Neill. Come on here with this COVID-19 teaching. Come on here, sir. So multiplying, this is what we're going to write down. Multiplying by a negative changes the location of the number on the number, y'all run out of room, line. I'd rather you write down number line, the whole word. Okay. So when I was negative, I'm far on the left, but now multiplying by a negative number is going to now put me on the right. When I was positive, I multiply by a negative. I'm over here on the right, but now multiplying by a negative number is putting me on the other side of zero. Teach, Mr. O'Neill. Come on in here. I wish I had an applause. Um, y'all, I couldn't sit. Come on in here and teach, Mr. O'Neill. Listen, you better be your biggest fan. I'm not playing with y'all. So, what conclusions can we make? What happens to the inequality when you multiply by the same number? Okay, if you multiply by a negative, inequality symbol flips. Let me show y'all something. Some people don't believe in division because every division problem can be written as a multiplication problem. So some mathematicians say there's no such thing as division. So if I divide a number, say for instance, I divide 8 by 2, that's going to give me 4, right? Dividing 8 by 2 is the same thing as multiplying by what? Who knows? Who knows? Who knows? All right, multiplying by 1/2. So I can say 8 times 1/2 is going to give me 4 as well. So this is the reason why this is the rule, and this is what you should write down. Well, y'all know it by now. I think you should know it. When you multiply or divide by a negative, the sign flips. The inequality sign flips because every division problem is really a multiplication problem. You can turn into multiplication. If I divide 8 by 4, that's the same thing as multiplying 8 by 1/4. All right? So that's the reason why the rule works with division and multiplication because technically they're like the same. All right? Okay, so let's move on. It's been 12 minutes. Oh, come on, Mr. O'Neill. You're doing good on time, sir. Come on and kill this time frame. Give these kids less than a 20-minute video. Come through here. All right, in the inequality, x is less than 3. That is not x heart 3, okay, or x heart. X is less than 3. X represents all numbers less than 3. Read the inequality starting on the side with the variable first. I need y'all to, you see that star? I'm starring it. I want you to pause the video and write that statement down. Read the inequality starting on the side with the variable first. You will be wrong if you read the inequality any other way. In fact, I just thought about the quiz that I just made for y'all. I need to throw a question like that in the quiz. So I will be editing the quiz before y'all get it. So read the inequality starting with the variable first. That's how you read it. So we're going to solve each inequality, make a quick graph. We're not going to write 3 numbers every time. That are the solutions to each. Okay, so we solve the inequality just like we solve an equation. Now, I don't do the balance line because it just looks weird to me, okay? So if you do the balance line, that's fine for you. If you want to draw a balance line, I don't because it just looks weird to me. So when we solve this, should you be writing this? You don't have to write this, all right? If you want to write it or take a screenshot of it, you can. You don't have to write this because this should be reviewed. Okay, if it's not reviewed for you and you feel like this is the first time you're seeing this, you might want to pause the video. I'm gonna leave that autonomy up to you. So we get x is less than 8. Okay, so how do I read the inequality? Read the inequality starting on the side with the variable first. I read this as x is less than 8. Actually, I do want you to write this down. I just changed my mind. Write it down, y'all. X is less than 8 because I need to make sure y'all know how to do these quick graphs. So when I make a quick graph, this is what you're going to do. Now I'm slowing down. All right, so you have 8 in the middle. This is how I make my quick graphs, and this is how I want you to make your quick graphs, no matter what your teacher necessarily said. Okay, this is how I want you to make your quick graphs. 8 is in the middle. We're going to put the integer to the right of that, which would be 9, and the integer to the left of that would be 7. So, I don't know why I left this out of your notes. Daggone it. So, I'm just going to introduce it now. So, because this is less than, the dot is going to be open because it's not equal to, right? The dot is open because it's not equal to. We are saying that x represents all numbers less than 8. X represents all numbers less than 8. And all numbers less than 8 is this way. Now, I'm going to correct something that sometimes your teachers teach you, and I'm going to do that right now. You do not shade where this arrow is pointing. Y'all see this? You see this right here? I am not shading over here because the arrow is pointing over there. No, I'm not. I don't teach that trick because I start now flipping inequalities and the X is on the other side. Nope. I shade over there because that's where all numbers less than 8 reside. I think I need to do something real quick. Let's just okay, I'm done. All right, that's the reason why I shade over there because that's where all numbers less than 8 reside. That is why I'm shading over there. What is this thing talking about? Oh, sorry. I thought I got a notification. My bad. Okay, my bad, y'all. My bad. Okay. All right. And so any number that's a solution that is less than 8 is a solution. So 7, -5, -384. All of those numbers are solutions. Okay, watch this. Write this down. Pause the video and write the second one down. Write the second one down. Subtract 12. Subtract 12. Right? I get -4. That. How do I read this? How do I read this problem? Starting on the side of the variable, it reads x is greater than or equal to -4. The mouth is open to the -4. X is greater than or equal to -4. You do not start with -4. You know why you don't start with -4? Because it says starting on the side of the variable. Y'all like the galaxy? You see the galaxy? So x is greater than or equal to -4. So, quick graph. -4 in the middle. To the right of -4 is not -5, it's -3. You're getting closer to 0. To the left of -4 is -5. Is this an open or a closed dot? It is a closed dot because we're saying it's also equal to. So we draw a dot. Where are we going? To the left or to the right? We're going to the right because that's where all numbers greater than or equal to -4 reside. To the right. Y'all think I need? I think I need. Come on. I think I need this. I don't know if this thing is recording the computer audio or not. I don't even know if y'all can hear that. It's gonna suck if y'all can't hear it. That means I have to insert some kind of audio so y'all can hear that. All right, so let's do the next one. We're gonna write this down. Number 3, Mr. O'Neill, you got like 2 minutes left. Maybe it's 25-minute video. All right, subtract 3 from both sides, y'all. Subtract 8 from both sides. We get x is going to be greater than or equal to -10. How do we read this? X is greater than or equal to -10. Why? Because we start with the variable. Okay, our -10 is here. Quick graph. Our -9 is here. Our -8 is here. And closed or open circle? Closed. Why is it closed? Because it's equal to. That means the number -10 is included in the solution. Are we going left or right? We don't look at those arrows. We read it. X is greater than. Where are all the numbers greater than -10 located? Right over here. All right. And then the next one. This symbol right here. God, I wish I was in class to show y'all this because I love asking this question. What is this symbol? It means not equal to. So we're going to make sure you write this down. Number 4. We're going to add 1, add 1. So we end up with 9 right over there, and M is there. How do I read this problem? I read this as M is not equal to 9. So M represents all numbers that are not equal to 9. We got our 9 here. We got our 10 here. We got our 8 here. Is this an open or closed dot? Well, if I'm not equal to, that means I'm open. But where do you shade? Well, if M represents all numbers not equal to 9, then M is everything but 9. So you shade this way. And the galaxy is beautiful. Y'all see this beautiful galaxy? Y'all see this? See the galaxy? and you shade that way. So what are some solutions? Well, 25 could be a solution. Negative 8 can be a solution. Negative 9.7, 9.32562 could be a solution. Why? Because that is not equal to 9. Those numbers are not equal to 9. What is the only number that is not possible for this graph? 9. All right, so for the sake of time, I'm not going to make this video any longer. I'm going to save those problems down there for class, and we will start there. I think this will be a good time to start in class anyway. Make sure you have your notes ready to go, and we're going to quit. Yay, I get to introduce y'all to this. So, this is my signature. This is how I sign off on all of my videos. This is Mr. O'Neal. This has been another Beast Mode production. I'm out.